Today we're going to be using Mogul, and you can find Mogul in CSD Core suite of our software. Mogul provides precise information on preferred molecular geometries. It enables you to validate molecular geometries rapidly using interactive plots and statistics, and it means it can help you identify any unusual features of a given query structure. Mogul incorporates pre-computed libraries of bond lengths, valence angles, torsion angles, and ring conformations derived entirely from the CSD, and it can validate complete geometries. If a fragment specified is rare, Mogul will include CSD results from the most similar fragments. Data is hyperlinked to Mercury, so you can explore structures in more detail, and Mogul is also integrated with other software. So when might you want to use Mogul? There are a number of different reasons for using Mogul, and here's just a few. So you could use it in teaching to help understand fundamental chemistry, or you could use it in industrial workflows to help design and assess new materials such as drug molecules. One of the main reasons it's used is to validate conformations. So you could use it to validate calculated conformations or to filter out protein ligand docking solutions with unlikely ligand conformations. Today, we're going to be looking at how you can use it to validate geometries to check the molecular geometry of a new crystal structure. Finally, you could also use it to create restraint and data ligand dictionaries. So you might want to do that for protein refinement or to help guide small molecule structure solution from powder diffraction data. Here is an example of how Mogul can be used in teaching to help students understand the different geometries in benzene and cyclohexane. In this tutorial, students use Mogul and experimental data in the CSD to help them determine typical carbon-carbon bond lengths in benzene rings. If we wanted to use Mogul in an industrial workflow to help design and assess new materials such as drug molecules, then it would likely form a part of a wider solid form informatic assessment. This is now a key part of solid form development workflow at most major pharmaceutical companies, where they're interested in learning more about the stability of their drug candidates. And you can see a couple of articles about solid form informatics here. So a number of different characteristics of the solid form can influence stability, as we can see on this slide. And you can see that molecular conformation is one of those influencing characteristics. So we can mine the CSD to identify intramolecular geometric preferences using Mogul. The data in the CSD can also be used to inform about new structures, and the knowledge base in Mogul enables you to assess molecular geometry of new small molecules. And it's also an important part of the process for protein structures. And Mogul is embedded in the PDB deposition pipeline, so depositors can check the geometry of their ligands prior to deposition. In a similar way, Mogul can also be used to help validate theoretical data sets as well. Well, firstly, Mogul libraries are created from data in the CSD, so organic, metal organic experimental structures. The Mogul knowledge base contains data on bond lengths, valence angles, torsion angles, and rings. Then some more of the details. Large distributions are reduced by random selection. Bond fragments and rings involving metals are characterized in exactly the same way as organic fragments. What's not included is bond angles and torsions involving hydrogen atoms, valence angles and torsions involving metals, cyclic torsions of rings less than 8 atoms, and rings containing less than 5 atoms. So that's the details, and now we can start using Mogul. So today, the main way we're going to use Mogul is through the Mercury interface. So if you want to start exploring Mogul 2 at this point, you'll need to navigate to Mercury in your start menu, or you can click on the Mercury icon on your desktop. This will open the Mercury interface. And we're going to be using Mogul from the CSD Core menu. And you'll see there's a number of Mogul options here. And the first one we're going to look at is Mogul Geometry Check.
And I am going to be looking at the first structure in the CSD. So that's ref code ARBUTS, AABHTZ. So if I click on CSD Core and Mogul Geometry Check, this brings me up a window Mogul search settings. And you can see some of the same filters that we see in Conquest on our desktop search application as well. So you've got some filters here. You can select your fragment types, and you can select the search mode. I'm just going to use the defaults and press search. I then get a dialog to tell me that no atoms were selected and it's going to run on the complete molecule. So I'll click OK, and then I get to see a search progress bar. Once that's run, it then opens a Mogul results viewer, and I can see my bond distances, angles, torsions, and rings listed in rows. These are all color coded. So blue is not an unusual value in the CSD, and there are enough hits. Pink is not unusual, but there are only a few hits. Orange, it's an unusual value in the CSD, and there is enough data. Browny red, it's an unusual value in the CSD, but there are only a few data hits in the CSD for comparison. So I can click through and I can see those color coded. So if I go back to ARBUTS, I can see a lot of blue, not unusual, with enough hits displayed for my angles. If I now do a single left click on a row, I can view the result in Mercury. So that then shows me the fragment and the measurement in my Mercury window. And I might want to do that to explore more about that particular part of the structure in 3D. So back to the results viewer, I'm now going to double click on a row. So I've chosen this angle C6, C5, ZL2. And I'm going to double click to open the view results window in Mogul. So this takes me to a window where a histogram is displayed. It shows the frequency of values and they're spread in the CSD. And I can see my value by the red line, so the value in my structure. I can see that different databases are also color coded. So in this case, I've got the main CSD database and the 2 data updates, and I can see those color coded. On the left, I can see which filters I applied, and I can also see some more statistics about the results here. On the bottom, I can see the number of hits and the number of hits selected. So if I click on the bars or the bins at the bottom, that deselects or selects the hits. If I click and drag, I can deselect or select a range. So that was the first tab, the results and analysis tab. If I then click through to view structures, I can view whichever structures I've selected, and the diagram button here takes me to a 2D diagram where the fragment is shown. I can click through the hits on this molecule, and I can also click through the hits of different structures in my ref code list, and I can see the number of structures at the bottom. If I then click up to information, I get to see more information, text numeric information about the structure in much the same way that we could in either Conquest or Mercury as well. For things like molecular geometries, things like disorder comments can be really useful. If I wanted to add extra text numeric information, I could do that by clicking on Customize and add something like temperature. If I then click through to the 3D visualizer, unsurprisingly, I get to see the structure in 3D. And again, I can click through the ref code list. So this is one of the structures with a relatively unusual geometry. And again, if I want to see more information or explore that structure in a bit more detail, I could then open that up in Mercury. And there I might want to look at things like the ellipsoids or the atomic displacement parameters. And a reminder, I could do that by going to Style
ellipsoid, or I might want to look more about the disorder of the structure. And you can see the disordered parts of the structure have been suppressed here and are coloured differently. So back to my Mogul window, and the last tab is Build Query, and we're going to be learning more about that later. So that's the basics of our Mogul geometry check, but there were other options back in Mercury that I could have looked at. So the first one, if I go to CSD Core Mogul settings, I get to see which Mogul data libraries I want to open. And you can see that I've got the main CSD and the 2 updates ticked here, but I could add other Mogul libraries or untick some of these. If I go back to Mogul geometry check, it opened up this Mogul search settings, and I had an option to change some of these, but I also could customize fragment classification. And here I can change some more details about my Mogul setup. Anything that I do change on these windows might impact the time it takes to run my Mogul search as well. So as well as looking at the CSD, we might want to look at an entry that we've determined. So to do that, we could load our structure in Mercury. So we'd go to File, Open, and open our own file, for example, a CIF. As a reminder, CIFs don't contain chemical connectivity information. So to assign bond types, we could go to Edit, Auto Edit Structure, Assign Bond Types, and we could do that every time we loaded a CIF into Mercury by going to File, Auto Edit Structure on Load to automate. Once I've done that, we'd follow exactly the same procedure as before. So CSD Core Mogul geometry check. So what we didn't see earlier in the slides was actually a Mogul query and building a query. So one of the first things that we're going to look at now is building a query, and these 3 options, the edit, auto edit and draw. So both the edit and the auto edit bring up respective boxes, and these are hopefully familiar to you. So this is exactly the same functionality that you would see in Mercury if you want to edit or auto edit a structure. So when we were looking at how to use your own structure and loading a CIF in, we already saw the auto edit. So the next one is draw. And if I click draw, that takes us to a draw menu. And again, this should hopefully look familiar. So it's the same draw window, or based on the same draw window as Conquest. It's got slightly different functionality, so it hasn't got all of the options, but it's more or less the same. So we'd use it in exactly the same way. On our website, there's a self-guided workshop, or we've already done a previous CCDC virtual workshop on Conquest. So if you do want to learn more about how to use the draw window, that would be a good place to start. So once we draw a query and draw a 3D molecule or 2D molecule, we would then press done. And by pressing done, Mogul will standardize bond types and add any hydrogens it detects is missing. And then it's then presented in our build query window. To select parts or fragments to search on, I can single click and left click on my atoms, and that will select and they'll be displayed in pink, and then I can decide to search. Also down this menu, so you can see it here and here, is settings. So I might decide to change some of the settings for Mogul before I do my query. So if I press settings, that opens up this Mogul search settings. And one of the things you might want to consider is whether you want the search to find exact hits only or generalized. So a generalized search will attempt to find related fragments if there are not enough hits that exactly match the query fragment. So depending on what you're looking for and how you want to construct your search, I'd recommend you look in the settings menu. It has got a number of different tabs. So again, we can see the filters and we can change some of the options for the bonds, angles, torsions and rings. So that's our build query tab and the draw feature in Mogul. So if we want to export data from Mogul, there are a number of ways that you can do that. In the Mogul results viewer, there's an export button at the top. That will allow you to export data as comma separated, HTML or XML. So if you're going to be putting it in a spreadsheet like Excel, you'd want to choose the CSV comma separated file. If I then clicked on one of the rows like we did earlier to bring up my histogram, I can then right click on the histogram to bring up an additional menu. So that allows me to change things like the font, the colors of our bars, to print my histogram, or I can export selected data. In this case, it tells me what data will be exported, so ref code and value only. There's a number of different publications that have used Mogul to do more in-depth research, and here's the first one that we're going to look at. So in this case, the authors investigated this molecule in the CSD, and they were looking at this nitrogen-nitrogen bond with a distance of 1.361 angstroms. If I run Mogul today, then I can see my value on the histogram, and it's off the peak of the histogram. So what the authors did, they did a Mogul analysis, and it actually led them it led to a redetermination of the structure in a different tautomeric form. So you can see that these bond types have now changed in the structure, and you can see that this distance is now closer to the peak of my histogram. So we could use the same approach on other structures in the CSD. And here we've got two structures that look very similar. So these are the ref codes. But if you look a bit closer, you can see the bonds are different. So you can see a double bond here or a double bond here. And a comparison in Mogul that queried the CN bond length finds that all geometrical parameters of the amine version to be within the expected limit. So I've put the references of some of the articles here. So if you want to look at how these authors have used Mogul in a bit more detail, you can look there.